Um, yeah, so in the last video we have seen that we are kinetics of particles. We have seen that. So we have seen the three methods in that. So D'Alembert's principle. So which gives summation of f minus ma equal to 0, and in work and energy method we have summation of f into distance half m v square minus u square, and then third one is impulse and momentum, and in this summation of f into t m into v minus u. So out of this you can see summation of f is something which you need to do for all the cases. So irrespective of the problems, we need to first frame the equation for the summation of forces. For different scenarios we need to frame the equation. So we'll just see some of the scenarios which will be coming across in the problem. The first scenarios will be lying in the blocks sliding. Okay, so in the scenario 1 we have a plane. Sorry about that, 1 second, let me make it straight. So I have a straight plane, and in that I have a block. So you are applying a force, let us say that is F. Okay, so now for the time being I'm saying just for F alone, one particular force. So in that case you have a motion in this direction. Okay, so in this case when you're dealing with this, so you will be having a friction at this regions between the block and the plane. You will be having a friction also. So in that case we will be dealing with a specifically called kinetic friction. So we have a coefficient of kinetic friction. So that will be given as between 0 to 1. Okay, so that is the relation between the block surface and the plane surface. So in that case we are dealing with the kinetic friction. That is the friction which will be considered when you are dealing with the under motion. When it is a under rest, then it will be considered for a static friction. So that will be given as mu s. So always remember in the terms of friction, mu s will be greater than mu k. So there will be a change in the kinetic friction when you are dealing with the movement. So that requirement to overcome that friction force will be lesser in the terms of movement. But when at the beginning, if it is in the rest, you need to give more forces in order to move it, overcome that particular static friction. So that is just another thing. We are not focusing on the particular. We are focusing only on the kinetic friction at the moment. So now, whatever that you're going to deal with will be under motion. Okay, so it will be under motion. So in that consideration, when we see we have a force which has been applied, so definitely you will be getting a friction force opposite to that. So that will be given by the term of friction subscript of F subscript of small f. So that will be a friction force. So these are the forces will be acting for this particular scenario. So in this case you will be getting a summation of F will be always you will need to consider the motion direction as the positive direction. So in that case, so motion direction is from left to right, so applied force is also F, positive right, so positive, and friction force is opposite of the motion, so minus FF. So F is something which is a normally applied force, whereas FF can be further expanded as, so where FF is the friction force which is derived from the normal reaction of the plane. Now when there is a block or anything which has been kept, you'll be having a reaction force coming in perpendicular to the plane. So in that consideration, So we have something called normal reaction, and so we will be giving that as FF is equivalent to product of mu into NR. Okay, so where NR is equal to normal reaction. Okay, so in this is a normal reaction, and we have already seen that mu is nothing but the coefficient of kinetic friction. So normal reaction is gained by normal reaction. Now in this case it's going to be weight of the block. It's equalized by the weight of the block, self weight of the block. So it will be W. So in that case, what we'll be getting is the summation of F will be F minus mu into NR, where NR is equal to W, so we'll be left with mu into W. So this is your summation of F for this case. So whatever method you're using, whether you're using D'Alembert's, whether you're using work and energy, whether you're using impulse and method, the summation of F for this scenario, this is the equation that you need to be adapted for the rest of the formula. So similarly, we'll also see different scenarios on looking at how to get the summation of F for the other cases. Okay, so we'll see it in the next video. Thank you.